Hello, my name is Mary Kate. I am a sophomore studying Biosystems Engineering and was giving example 3 for the video project. So the first question we have is to evaluate the limit as x approaches -1 from the positive side of the equation square root x plus 1 minus 1 over x. So the first thing we want to do is make sure that we have this positive sign and that it's coming from the positive end and not the negative end. So I'll just rewrite it. Limit as x approaches -1 from the positive side, root x plus 1 minus 1 over x. So from the positive side, we just mean that if the limit, we wanted it right here, this would be coming from the negative side or the left, and then this would be coming from the positive side or the right. So this is a right-hand limit. So the first thing we do after you write out your equation is to take the limit of each term. So from this, I'm going to take out the, so it's going to look like this, square root the limit as x approaches -1 from the positive end at x plus the limit x approaches -1 from the positive end at 1 minus the limit x approaches -1 from the positive end at 1. Then we put that all over the limit x approaches -1 from the positive side at x. So what we do with these numbers is evaluate the limit by plugging in -1 for all the occurrences of x. So right here we plug in a -1, right here we plug in a -1. So we'll use a number color. We'll put in 1, we'll put in -1 and a -1. So if we put in a -1 at these places, then our limit looks like this. -1 plus 1 minus 1 over -1. So if we simplify this, -1 plus 1 is 0. So the square root cancels. So it's -1 over 1. So the answer is 1. Just highlight that. So our final answer is the limit as x approaches -1 from the positive side or right side of the equation x plus 1 minus 1 over x is equal to 1. You could also cut down this step by replacing wherever you see an x with -1. So just replacing -1 right here, -1 right there. So the second part of our question is true or false. The limit as x approaches 0 of the equation absolute value of x over x equals 1. So how we do it is a left-sided limit, so we should consider that. So it is coming from the left. So I think how we should approach this is start to make a table of x and y values if we plug it in. So if we plug in negative 0.1, you get negative 1. You get plug in negative 0.01, you get negative 1. You plug in negative 0.001, you get negative 1. So this table shows the behavior of the function absolute value x over x as x approaches 0 from the left. So as the x values approach 0, the function values approach negative 1. Thus, the limit of x, absolute value of x over x as x approaches 0 from the left is negative 1. But now we have to consider it from the right. So if we consider the function from the right, and we make our table again, we get as x approaches 0.1, 0.01, 0.001, you get that the function is approaching 1. So as the x values approach 0, the function values approach 1. Thus, the limit of the absolute value of x over x as x approaches 0 from the right is 1. So this equals negative 1, and this equals 1. Then the limit as x approaches 0 for the function absolute value of x over x does not equal 1. It does not exist, therefore making this statement false. If a limit is different, so let's graph it just to show how we would do this. So if the limit equals negative 1 over here, so the function is approaching negative 1, and then the function is approaching 1 from the left side, there's a disconnect, and the limit does not exist here. Thank you for listening, and have a nice day.